People engage in economic activity that requires energy, mostly supplied by carbon-emitting sources. This very short sentence is at the core of the energy and climate issue. From the last video, we asked the following question: how can we provide enough energy to support the economic development of more than 10 billion people all around the world without affecting the climate system in the future? This question stems from the Kaya equation, named after a Japanese economist, Yoshi Kaya, who developed in the 1990s a very simple model to assess the factors driving the growth of greenhouse gases emissions. For Kaya, the evolution of the carbon emissions is the product of four factors: the evolution of the carbon content of the energy we consume, or CO2 over energy, the energy intensity of our economic activity, generally measured by the amount of energy consumed per unit of gross domestic product, the wealth per person, or GDP per capita, and the growth of population. If you remember the last video, all UN member countries agreed in Paris to reach a level of net zero emissions as soon as possible in the second half of the 21st century, to be in line with the objective of limiting the gross temperatures at plus 2 degrees Celsius. Many scenarios exist to explore the future trends compatible with this goal. Let me propose a simplified one. In order to limit the rise of temperature to 2 degrees, we collectively need to divide our emissions by 3 between today and 2050. According to the most recent UN estimates, the global population is going to grow by 30% between today and 2050. At the same time, assuming that the global GDP per person is going to grow in the next 35 years as fast as it did in the last 35, this means that the term GDP per capita will grow by approximately 60% by the mid-century. To sum up, this means that to cut global emissions by 3 in 2050, with 30% more people and a 60% higher GDP per capita, we need to divide the two other terms of this equation, CO2 over energy or energy over GDP, by more than 6. In other words, we need to reduce every year by more than 5% the carbon content of the energy we consume, or to reduce the amount of energy needed to produce 1 unit of GDP. The graph next to me represents the life cycle greenhouse gas emissions from different sources of electricity. The bars show the result of a range of studies assessing the carbon content, here measured in grams of CO2 equivalent, for each kilowatt-hour of electricity produced. Very clearly, decarbonizing the energy mix implies to shift from our 80% fossil fuel mix towards low-carbon sources like hydro, wind, solar, or bioenergy. We can see that we could also reduce CO2 emissions by supplying more of our energy needs with nuclear, or to capture and store the carbon emitted by fossil fuel sources. If we take a look at the past, the carbon intensity of the world primary energy supply is the same today as it was 30 years ago. After a slight decline in the 1990s, it went up after 2000 due to the fast-paced economic development of several Asian countries, supported by intensive consumption of coal and oil. Definitely, we are not on the right track, and decarbonizing our energy consumption is a key challenge for the years ahead. If you look now at the energy content of the GDP, which is a good proxy to measure gains in energy efficiency, the picture is slightly different. On average, the primary energy supply required to produce 1 additional unit of GDP has decreased by 1% per year, reflecting improvements in our industrial processes, but also an expansion of the service sector in the global GDP, which is less intensive in comparison with heavy industries, for example. Still, we are far from being in line with the requirement of -5% per year decrease of the global carbon intensity of the GDP, what is expected in a +2 degrees Celsius compatible scenario. To sum up what we discussed during this video, let's remind that greenhouse gases emissions are driven by the growth of population, their economic activity, but also the energy intensity of the GDP and the carbon intensity of the energy we consume. Because population and GDP will probably keep growing in the future, we need to cut the energy intensity of the GDP or the carbon intensity of the energy mix by 5% per year to cope with the Paris Agreement long-term objective. Many solutions are possible: more renewables, more nuclear, or capture and storage of emissions from fossil fuels combustion. But for the time being, we are not on the right track. This is the challenge we will try to tackle during this MOOC. What are the solutions to shift towards an affordable, reliable, and decarbonized energy mix able to satisfy the needs of a soon-to-be 10 billion people planet? Welcome in the MOOC. Let's get started.